think the way that we've generated energy in the last 100 years from essentially a single point of fossil fuels is not sustainable. Either by the end of this century or clearly moving on, we need to have other strategies. So I think what we're doing in the center is critical to this energy grand challenge that I talked about, because it's helping us diversify how we source energy for society. And we're evaluating the potential for how one specific part of the biofuels area, cellulosic biofuels, can contribute to that energy equation that society will need to live on. The sheer body of work that we've been able to do in the first 4.5 years, it has been actually more than I ever anticipated we would get done. What's more important, I think, is the approach that we've taken to roll out and assemble the Great Lakes Bioenergy Research Portfolio. We have decided to take an approach that doesn't focus on one particular feedstock, one particular plant biomass, or one particular product that comes out of it. We've decided to take an approach that allows us to try and extract as much energy from a diverse set of crops and convert it into a small number of fuels that will function in the automotive, aviation, and diesel engine sector. And we've done that in a way to develop technologies that we think will be sustainable. And the sustainability of these technologies from the field through to pump will really be critical in getting consumer and society acceptance into the types of new fuels that we're going to be generating. Great Lakes Bioenergy, I think, should be very proud of bringing together these teams of people from a wide variety of disciplines to work on a common problem. Those individuals have bought into the science that we're doing and the approach that we're taking. And by that I mean they have embraced the idea of working together in teams to solve problems in a way that we traditionally would not have been able to do without the significant amount of funding that we got from the DOE Office of Science.
Producing sugars from plants is really a key obstacle on the road to producing fuels and chemicals. Most of the time, the way people have done it in the past is that they've used expensive chemicals or biochemicals such as concentrated acids, enzymes, or ionic liquids to get those sugars out of the plants. And what we've discovered is that by using gamma-villarylactone, or we like to call it GVL, which is a molecule you can easily produce from plants themselves, we can promote the deconstruction of these plants into sugars even while using very low acid concentrations. So it provides us with a really cheap and green process to produce sugars in a mixture of GVL and water. That's great so far, but what we really want to do is to produce sugars in water by itself and be able to recycle and reuse the GVL, otherwise it just gets too expensive. So what we typically get out of our reactor is something like this, which is a mixture of the sugars in GVL and water. And what's really impressive about this system is by just using fairly simple additives, we can transform the system so that the water will spontaneously separate from the GVL and take all of the sugar with it. So now what we've got is a process that allows us to produce a concentrated phase of sugars in water. And once you're at this stage where you have the sugars from biomass, you really have a lot of possibilities. You're at the first fork on the conversion road between plants and fuels to chemicals. You can go down the biological road and ferment those sugars to things like ethanol, butanol, or even other much more complex commodity chemicals or fuels. But we can also go down the chemical route and further chemically process those sugars to things like maybe hydrogen or liquid alkanes, things that look a lot like gasoline. This is really a process where we've demonstrated a new chemical route to produce sugars, this very versatile intermediate using a solvent that can easily be produced from biomass itself and requires very little of anything else, just a little bit of acid. And so we think this is really a potentially cheap and much more efficient way of producing sugars and could enable biomass conversion to fuels and chemicals.
So what is a next generation biofuel? So this kind of gets back into a series of classifications for different types of fuels. And so today, if you went to the pump, the biofuels that you would see are ethanol and biodiesel. And so by definition, those would be first generation biofuels because they're there today. What we're looking for down the road is fuels that are seamlessly integrated with our current fueling infrastructure. So instead of having a gasoline pump, we would have a biogasoline pump, or instead of a diesel pump, we would have not necessarily a biodiesel pump, but a green diesel or a biologically derived diesel. And so these next generation biofuels or advanced biofuels are molecules that would be integrated seamlessly. So they would have the same molecular composition, the same properties as today's petrochemically derived biofuels.
My name is Claudio Graton. I'm in the Department of Entomology, and I'm here in the Wisconsin Energy Institute. And the things that we work on in my research group are really trying to understand how insects that we care about, things like bees and lady beetles, things that carry out functions that we care about, like pollination and feeding on crop pests, how they're affected by the environment and how we can conserve them in the environment. And one of the things that we're excited about in relation to bioenergy is that some of the crops that we can put out there, like switchgrass or diverse prairies, actually have the potential to be places where we can conserve those beneficial insects and therefore to enhance their ability to carry out the services that we care about in the landscape.
I'm Rachel Mallinger, and I am a PhD student in entomology, working with Claudio Graton here at the Wisconsin Energy Institute. I study bees, and the bees that I study are native bees, native to Wisconsin, and I'm studying how both land use change and agricultural management affect these bees. With biofuels and bioenergy, we're looking at how planting various bioenergy crops like corn or switchgrass or mixed prairie, how those changes in the landscape will affect bees, and then also how the management of those crops affects the bees as well.
I really think my own research has benefited tremendously from being in a place like the Wisconsin Energy Institute. And one of the main things I think it's forced me to do is to really think outside of the normal questions that I'm interested in. And really, it's forced me to think about the so what questions. The Wisconsin Energy Institute is really aimed at solving real problems. We're constantly challenged by our colleagues to make the research that we do relevant to answering those questions. And so we've really tried to align the kinds of experiments that we do, the questions that we ask, to really address the question of so what. So it's been great for me, and sometimes that's actually meant that I have to do my research in a slightly different way. If I can't make that connection tangible, well, maybe it doesn't matter as much as I hope that it does. And so I end up changing the kinds of work that we do to make it more relevant to the particular questions.